In this video, we're going to be talking about reflection of light on plane surfaces. Now, reflection of light is the process whereby light bounces off a surface after striking the surface. Alright, so this is what reflection looks like. We have light rays or a ray of light striking a surface and then bouncing off the surface afterwards. The ray that strikes the surface is known as the incident ray. Okay, so this is our incident ray. The one that strikes the surface is called the incident ray. And then the ray that bounces off the surface is known as reflected ray. This one bounces off the surface, so it is called the reflected ray. Now we also have what we call our angle of incidence. The angle of incidence is the angle the incident ray makes with the normal to the surface. Every surface will always have a normal. The normal is just a straight line that is perpendicular to the surface. So this is our surface, and then this is the line that is perpendicular to it. That's the normal to the surface. Alright, so the angle of incidence is the angle the incident ray makes with the normal. We call it the angle of incidence. Very important. And then the angle of reflection is the angle the reflected ray makes with the normal. Angle of reflection, angle reflected ray makes with the normal. That's what we call angle of reflection. All right, you can see it here stated: angle of incidence, angle incident ray mixed with the vertical, which is also the normal to the surface. Angle of reflection, angle reflected ray mixed with the vertical. All right, reflected ray mixed with the vertical, as known as the angle of reflection. The vertical is also known as the normal to the surface. Now we also have our laws of reflection, which is very, very important. Laws of reflection. And the first law here says the incident ray, reflected ray, and normal are the points of incidence all lie on the same plane. Now if you look at this diagram, we have incident ray, reflected ray, and the normal to the surface. Now this is our point of incidence. Alright, you discover that at the point of incidence, they are all on the same plane. That is the number one law, or number one here, which is the first law of reflection. Now the second law, we have that the angle of incidence is equal to the angle of reflection. All right, angle of incidence is equal to angle of reflection. This is very important. You need to always remember that angle of incidence is always equal to the angle of reflection. That is number two. Okay. Now, aside this, we also have what we call our angle of deviation. All right. Now you observe something, that the incident ray moves along this path until it was reflected. All right. If not for the fact that it was reflected, it should have continued along the same path. This is the path of the incident ray. The incident ray originally would have continued on this path, but then it was reflected. Now it was reflected through an angle. All right. And the angle through which the incident ray is reflected is what we call the angle of deviation. The angle through which the incident ray is reflected is what we call the angle of deviation. All right, and the symbol is the angle of deviation. Now the angle of deviation has a formula, and what's that formula? To get the formula for solving angle of deviation, it's very, very easy. All you just need to remember that is that this is a straight line, and the sum of angles on a straight line is equal to 180 degrees. That's to say angle of incidence plus angle of reflection plus angle of deviation equals 160 degrees. So write it 180 degrees. So we have angle of incidence plus angle of reflection plus angle of deviation, all right, equals 180 degrees. Why? The sum of angles on a straight line equals 180 degrees. Now you also need to remember the angle of incidence equals angle of reflection. So in that case, rather than writing I plus R, in place of R we can write I, because I is also equal to R. Alright, so we can say angle of incidence plus angle of incidence plus angle of deviation equals 180 degrees. That will give us I plus I, which is 2i plus angle of deviation equals 180 degrees. If we make angle of deviation subject to the formula, we're going to move 2i to the right side of the equation. It becomes angle of deviation equals 180 minus 2i. Alright, so this is one equation for calculating angle of deviation. It's either you work with this, or you can also have that angle of deviation is equal to 180 minus 2 times angle of reflection, because angle of incidence and angle of reflection, they are the same, they are equal to each other. Now another equation we can use to calculate angle of deviation is, we can say angle of deviation is equal to 2 times the glancing angle or angle of glance. All right, now the glancing angle, also known as the angle of glance, is simply the angle the incident ray makes with the plane of the surface. These are angle of glance. Angle the incident ray makes with the plane of the surface, angle of glance. And by the time we add these two together, we're going to have 90 degrees, or the sum of these two is equal to 90 degrees. All right, so now let's try out some questions and see the applications of these equations. Now this question here says, if light rays intersect a plane mirror at an angle of 25 degrees from the vertical to the surface. All right, find the angle between the incident ray and reflected ray. So this is a very easy question. Let's try to, sketch the diagram for this question. All right, now on our diagram, you discover that we have the incident ray and the reflected ray and the normal to the surface. Like I said, every surface will have a normal line, all right, which is also the vertical. Now they said if light rays intersect a plane mirror, we can take this to be mirror. This is the back of the mirror and this is the reflecting surface. If light rays intersect a plane mirror at an angle of 25 degrees from the vertical, light ray, all right, it hits a plane mirror. Okay, this is the one that intersects the plane mirror at an angle of 25 degrees to the vertical. So we have from the ray that strikes the mirror to the vertical, we have 25 degrees. Light rays intersect a plane mirror at an angle of 25 degrees from the vertical. So we have a vertical or normal to the surface to the light ray that intersects the mirror. Now they said find the angle between the incident ray and reflected ray. So this is what we're looking for. All right, from the incident ray to the what reflected ray, the angle that is formed. All right, the angle that is formed. Now looking at this question, what are the parameters we're given? 25 degrees is the angle between the incident ray and the normal to the surface, and that's what we call angle of incidence. If you recall, angle of incidence here is equal to 25 degrees. And if we have angle of incidence, we can also get angle of reflection. All right, angle of reflection is equal to angle of incidence. All right, and that's equal to 25 degrees also. So it simply means this angle here will also be 25 degrees. So our question says find the angle between the incident ray and reflected ray. So we have from incident ray to reflected ray, the angle formed between the incident ray and reflected ray is simply the sum of these two angles here. All right, so simply add up this 25 plus 25 and that will give us 50 degrees, which is option B. Now moving on, in this question they said the diagram below shows a ray of light IK incident on plane mirror at K. Okay, calculate the angle of deviation. This is a very straightforward question. There are two ways we can solve this question actually. We're looking for the angle of deviation. Angle of deviation. Now in this question you discover that they gave you the angle of glance. Don't forget the angle of glance is the angle incident ray makes with the plane surface. All right, makes with the surface. So they give us angle of glance to be 35 degrees. Okay, so from here we have that our glance angle is equal to 35 degrees. So angle of deviation, which is equal to 2 times glance angle, will now be going to have angle of deviation equals 2 times angle of glance is 35 degrees. 2 multiplied by 35 which is 70 degrees. So that is angle of deviation. Now, a second approach to solving this is to bring out our normal to the surface. So let's draw out our normal line. Okay, so let's say this is our normal line. All right, we have the incident ray. Now this is reflection. Obviously, we're going to have the reflected ray. All right, so this is the reflected ray. Incident ray, reflected ray. Now looking at our question, what will be our angle of incidence? The angle of incidence is the angle formed between the incident ray and the normal to the surface. So we'll label it angle of incidence. And then angle of reflection is the angle formed between the reflected ray and normal to the surface. So also label it angle of reflection, angle of incidence. What we need is angle of deviation. And the second equation for angle of deviation is that angle of deviation is equal to 180 minus 2 times angle of incidence. So what's our angle of incidence here? It is very easy. All we need to do is we need to understand here that this normal to the surface is perpendicular to the surface. So from this point here, all right, to this point here, we have 90 degrees. Okay, so the whole of this is 90 degrees. So it simply means I plus 35, all right, that's this plus this is equal to 90 degrees. All right, so the angle of incidence will now be 90 minus 35, which is equal to 55 degrees. This is our angle of incidence, 55 degrees. Now to get our angle of deviation equals 180 minus 2 times the angle of incidence. So come down here, angle of deviation equals 180 minus 2 times 55 degrees. And that will give us angle of deviation equals 180 minus 110. And that's equal to 70 degrees, which is the same answer as what we have here.